Okay, so getting ready 7. We are once again working with literal equations. So we will be choosing one variable out of an equation that has 2 or 3 or 4 variables and isolate that chosen variable. So in number 1a, we have the Celsius to Fahrenheit equation, and we are trying to isolate to solve for the variable f. Now that f is inside parentheses. So one option would be that you could distribute the 5/9 and then solve for f. I'm going to choose to show you another method. I'm going to leave the f where it is inside the parentheses, and first I will cancel this 5/9 that's in the front of the parentheses. Since that is multiplying by 5/9, if I multiply both sides by its reciprocal, 9 over 5, it will cancel the fractions on the right. I will have 9/5 c is equal to, and now there is no longer need for the parentheses since the only thing on the right-hand side is f minus 32. Now, to finish isolating the f, I just add 32 to both sides. So I have 9/5 c plus 32 equals f. B, we have the formula for the volume of a cone, and we are going to solve for the variable h. So let me recopy this here. V equals 1/3 pi r squared h. Now, technically, you could do this in one step. That's probably not wise, as we're still a little new at this. So first, let me get rid of the fraction. Since it's multiplying by 1/3, I can multiply both sides by the reciprocal 3 over 1. That cancels the fractions on the right, leaving me pi r squared h. And on the left, 3 over 1 times v is 3v. Now, since I want that h alone, it's being multiplied right now by pi and by r squared. I can consider that to be all one quantity and divide both sides by pi r squared, all in one step. It's canceled on the right, leaving me the h alone as I wanted, and on the left I have 3v over pi r squared. In part C, we have the area formula for a regular polygon. Area equals 1/2 times the perimeter of the base times the apothem. So we are solving for the perimeter P. So to isolate that P, again, I could probably do this in one step. I'm not going to. I don't want to confuse you. So to get rid of the fraction first, multiply both sides by 2 over 1. So 2a on the left, 2 times capital A, equals the 1/2 times 2 cancels. I have perimeter times lowercase a apothem. One more step to get rid of this lowercase a on the right. I will divide by little a on both sides. So the perimeter is equal to, now the capital A and the lowercase a are not like terms. They stand for totally different values, so you cannot combine them. It is just 2 times area divided by apothem. Part D, formula for perimeter of a parallelogram. Perimeter equals 2 times the length plus 2 times the width, and we are going to solve for W. So to isolate this W, I first need to get rid of the 2L. So that's a positive 2L. I'll subtract 2L on both sides. On the left, it remains P minus 2L. On the right, I have just 2W. To now get rid of the multiplication by 2, I will divide both sides by 2. So I'm left with W equals P minus 2L over 2. And as we did in yesterday's homework, if we wanted to split that up into 2 separate fractions and reduce them each, this could be 1/2 P minus L. but this answer is also fine. Part E, we have the slope-intercept form of a linear equation, y equals mx plus b, and we're going to solve that equation for m. So to isolate that m, we'll first get rid of positive b by subtracting b on both sides. Y minus b equals mx. And to now get rid of the x, it's multiplied, so we'll divide both sides by x, leaving us y minus b all divided by x equal to m. Or, again, if you split it into two separate fractions, that's y over x minus b over x is equal to m. And part F, same equation, y equals mx plus b. This time, though, rather than solve for m, we're going to isolate the variable x. So the steps will seem very familiar. You will still start by subtracting the b on both sides. Y minus b equals mx. But now, since we want the x to remain where it is, we want to get rid of m. That means divide both sides by m. So x is equal to y minus b all divided by m, or y over m minus b over m is equal to x. Part G, we now have standard form of a linear equation, capital AX plus capital BY equals capital C. So we are going to solve for the variable x. We want x to remain where it is, everything else to move away. So start by subtracting the by on both sides. I'm left with a times x equals c minus by. And to eliminate the capital A, you divide both sides by a. So x is equal to c minus by all divided by a, or x is equal to c over a minus by over a. In part H, we have that same equation, and this time we're just going to choose to solve for y instead of for x. So y is to be isolated. This time you'll subtract the a times x, leaving you by equals c minus ax. To get rid of the b, divide both sides by b. So y is equal to c minus ax all divided by b, or if you prefer, y is equal to c over b minus ax over b. Okay, and lastly at number 2, we're going to go back and look again at the Celsius and Fahrenheit conversion formula. This one says Jasmine and Jordan are using that formula to convert temperature expressed in degrees Fahrenheit into temperatures in degrees Celsius. They rewrite the formula and their work is shown below. Why do they look different? Did either of the students make an error justify that? Well, let's look at each individual student. So Jasmine's work is solved for C, and she starts by multiplying both sides by 9 to get rid of this fraction. So multiply both sides by 9. On the left, you get 9c, no problem there. On the right-hand side, the 9 cancels the 9 in the denominator of the 5/9, leaving us just 5 times the quantity f minus 32. Her next step, she decided to distribute the 5. 5 times f is 5f. 5 times negative 32 is negative 160. And lastly, just to move the 5f to the left-hand side to join the 9c, she subtracted 5f on both sides. So 9c minus 5f is equal to, she didn't even lose her sign, negative 160. So that one's good. So let's look at Jordan's work. Jordan started with the formula that was solved for f. So he's trying to do the same thing. He's trying to rearrange it so that f and c are on the same side. Let's see his work. His first step, he also chose to get rid of the fraction by multiplying both sides by 5. So 5 times f is 5f. 5 times 9/5 c is 9c. And 5 times 32 is 160. So far, so good. He then decided to rearrange. He has moved the 5f, he has subtracted 160 from both sides. So the left side would say 5f minus 160. The right-hand side would still have 9c. But then he just rearranged, he switched sides and put the 9c on the left, the 5f minus 160 on the right. And then to put both variables on the same side, he subtracted 9c. Here's where he has a mistake. 9c minus 9c should leave 0 on the left equals 5f minus 9c minus 160, which does not look the way he wrote it at the end. It does not look the way he wanted it to look. So what could we have done instead? If we want the variables both on the same side, it would make sense to bring the 5f to the left to join the 9c. And we do that by subtracting 5f on both sides. So rather than his final result, we would end up with 9c minus 5f equals, cancels, negative 160. And now Jasmine and Jordan's work can result in the same answer.